Welcome to Professor Anselka's Math Online Lessons. With me here is a question from 2023, question number 3A under calculus. I want us to look at this particular question. It's question number 3A of section A, paper 2. This is the November paper that was written by the internal candidates for last year. So the question is on question 3A. That's question number 3A on calculus. Let's see how we go about this question. The question says, find the equation of the curve for which dy dx equals to 12x cubed minus 4x plus 5 at the point where x is 0 and y is minus 2. Okay, so copy the question. That's 3A, question number 3A. Copy it and follow me as I explain how to find the equation of the curve. So before we proceed, I want to give you just an example. For example, if you have something like, if you have the curve y is equal to 2x squared minus 4. If y equals to 2x squared, say plus 4. Take note. If you have something like this, then you're asked to differentiate. You're going to have something like dy dx, and this will equal to this 2 we multiply by this 2 here. So we're going to have 2 by 2, that's 4 x, then this 2 we're going to subtract minus 1, and you just have control of just 1. Then say plus, if you differentiate a constant you always get 0, so here I've got a 0. Then you simplify this, we're going to have dy by dx equals to 4x squared plus 0 is just 4x. Now remember, differentiation is the reverse process of integration. So differentiation and integration, these are reverse processes. So what we've been doing here, we've been differentiating. Now let's see how we can reverse this particular answer to the question. Let's see how we can reverse it. So when you reverse this one, we use what we call integration. So I need to integrate. That is to reverse this particular answer to the question. Okay, so what you do here is we're integrating with this particular symbol. Remember the answer here is dy dx equals to 4x. This is the answer, right? Now I want to reverse this one. So we're going to integrate. We use this symbol here, the integral symbol. So integrate dy over dx with respect to x, that's dx. You write dx, and this will equal to. So you integrate the dy dx, the gradient notation, okay, and also the function itself, 4x here. So we're going to integrate this, that's the integral of 4x inside the parenthesis, then say dx. Take note, very important. Now let's start. So if you integrate the notation dy dx with respect to x, we're just going to have y. So here we've got y, and this will equal to, if you integrate the 4x, you see that we're going to have 4x to the power 2, and everything divided by 2, then say plus c. Plus c is the constant of integration, meaning it represents any number that can be here. It can be any number, either positive or negative number. Okay, take note. Then here we're going to have y equals to, when you simplify this, we're going to have 2x squared plus c. Take note. If you check, this is the exact thing that we actually have here. Okay, that's actually what we have here. Take note. This is actually what we have here. You see? Okay, so this 4 corresponds to this c. Check it out. Okay, it's actually the y-intercept. So time to do this one here. This is very, very important. Okay, that's what you do. And this is the same concept we're going to apply to this particular question here. The question says if dy dx equals to 12x cubed minus 4x plus 5 at a point where x is 0 and y is minus 2, find the equation of the curve symbol. So with this in mind, let's see now how we answer this particular question. Let's see now how we answer. Okay, so we continue. So we have this particular question. If the gradient, which is the dy dx, is equal to 12x cubed minus 4x plus 5 at a point where x is 0 and y is minus 2, can you find the equation of the curve? Find the equation of the curve. How do you go about this one? So the similar thing will apply here. So since this is the gradient, this particular function, the curve was differentiated, we need to integrate to get back to the curve. Okay, we're trying to find where this is coming from. So this is coming from a curve, and for us to get back to the curve, we need to integrate, we need to reverse. Okay, we need to reverse this differentiation to integration so that we get back to our curve. So we're going to integrate the dy dx notation. So we say the integral of dy dx with respect to x equals to, we say the integral of this whole lot of this function with respect to x. Now let's see how we go about this question here. So if you integrate the dy dx, notation with respect to x, here we just have y, and this will equal to the integral of 12x cubed, we're going to have 12x to the power of 3 plus 1. Take note, everything's a 3 plus 1. Then here of minus 4x squared, because this is 1 plus 1, take note, this x is 1 plus 1, then everything's a 1 plus 1 here. Then say this is plus, this is 5, this constant number, it is actually x here, so there's x to the power 0, so add plus 1 and everything is 0 plus 1, take note. Okay, at the end of the day we're going to say plus c, the constant of integration. Very important, you add the plus c. Okay, let's see, we simplify this particular function. We're going to have y is equal to 12x to the power 3 plus 1, that's 4, over 3 plus 1, that's 4, minus, we've got the 4x to the power 1 plus 1, that's 2, everything over 1 plus 1, that's 2, then say plus, observe, here we have 5x to the power 0 plus 1, that's 1, over 0 plus 1, that's 1, take note. So you're going to have x to the first power over 1, then say plus c here. Then as you go further, now we simplify this particular function. We're going to have y equals to 4 into 12, that's 3, x to the power 4, minus 2 into 4, that's 2x squared, plus 5x here, plus c. You see, that's what you do, right? Once you do this, now we need to make sure that we find what c is. Take note, we need to find what c is. Now remember, we're given to say at a point where x value is x value rather here is 0, and the y value here is minus 2. So I'm going to plug in these two values of x, these two values, that is to say of these two variables x and y. So where we have the x, we're going to put 0, and where we have the y, we're going to put minus 2. So here we have the y, we're going to put the minus 2, observe. So we're going to have minus 2 equals to 3, you open the parentheses, we have the 2, you open, put 0 there, you have the 5, you open, put a 0, and then say plus c. So you see that all these have got 1, 2, 3 terms are multiplying by 0, and we're going to have nothing. So from here up to here we have nothing. Nothing plus c is c. So c here we know is minus 2. Therefore, the equation of the curve under review, take note, we'll just substitute where we have the c here, put the minus 2. Take note. So therefore, we say the equation will be y equals to 3x to the power 4 minus 2x squared plus 5x. Finally, where the c we put minus 2, and this is actually the curve being asked. This is the answer. Go through the process, is very easy. go through the process. Is very, very easy, and that is the particular answer. And this is true. If you want to reverse this, you can now remember we've been integrating. Now to reverse this one back to the statement above, back to this one, will be required to actually differentiate this particular function. If you differentiate this particular function, we arrive at 12x cubed minus 4x plus 5, which is true. If you differentiate this, we're going to say 4 by 3, that's 12. 12x, 4 minus 1, that's 3. You're going to have minus 2 times 2, that's minus 4x. Then you're just going to have, plus 5. Okay, we're just going to have plus 5 here, which is true. And the constant minus 2, remember, the gradient of a constant or a number is 0. So minus 2 is out. Okay, then the gradient of 5x is just 5, it's just positive 5. And this will take us back to this particular question. You see? So that's how it is, and that's how simple it is. Thank you for watching. Please endeavor to like the videos and subscribe so that each time we upload these videos, you're notified. Thank you for your time.